last session of the show. How many of you are completely brain fried? Show of hands. Yeah. Pretty much everybody. The ones who didn't raise their hand are like, what do you say? Just out of curiosity, how many of you actually like the JavaScript language? 3, 4 hands and a lot of maybe, kinda, sort of. Well, if you like JavaScript, leave. No, seriously, leave. Go away. You are not welcome here. Because what I'm trying to do here basically is show the folks who don't like JavaScript. Because let's be clear, JavaScript as a language is really one of those things that honestly only a mother could really love, right? And you know, we love the fact that JavaScript is an established standard. We love the fact that its ubiquity via the browser means that we have a target that we all know will work. Wink, wink, he said. Without a hint of sarcasm, you'll know. But let's be blunt, the language was invented over a weekend, right? And there are a lot of things about the language that are, in fact, hard to love. So, one of the things that has emerged because of this fact, we like its reach, we like its ubiquity, we like the fact that it gives us a tremendous amount of power in the browser where we haven't historically had a great deal of power. Allows us to do a number of things at the user interface level inside of the browser that, again, if you are like me and you've got, gray in your hair somewhere, you remember the days of trying to build interactive applications using nothing more than HTML 3.2. All right, yeah, there's a few nodding heads going, yes, I remember those. And there's like one person in the back going, please don't remind me. The JavaScript target is a good thing. We're just not a super fan of the language. Well, those of you who are not a big fan of the language, there is alternatives. As a matter of fact, this is a subset. Josh, I can't remember his first name, Jay Ashkenaz, down here, Jash Kenaz. And we'll just pop over here to a browser. Browser? Please no porn, please no porn. Okay, cool. List of languages. Here we go. So Jash Kenaz is the one that actually created CoffeeScript, which we'll talk a little bit about. But as part of the wiki for this particular GitHub project, he created a list of languages that compile to JavaScript. Some extensions to JavaScript. Some language extensions. Apparently, Ruby to JavaScript is kind of a popular thing because there's like a dozen options there. Python to JavaScript, 2 dozen. Erlang, only 3. Elixir, Perl, who cares? Perl, go away. Java to JavaScript, Scala to JavaScript, .NET to JavaScript, Lisp and Scheme to JavaScript. There's a certain amount of irony there. OCaml, Haskell, Smalltalk, C and C++, Basic, Pascal, Go. Are we done yet? SQL to JavaScript. God help us. I mean, seriously, there is like a JavaScript flavor of everything, right? Yeah, so just because I'm going to talk about a few, and there's no promise, by the way, that this list is comprehensive. JavaScript is one of the greatest targets for a variety of languages. If you saw the Kotlin talk, that was, I think, earlier this afternoon, Kotlin will also target JavaScript. There are so many languages, so many compilers that will actually target JavaScript as a target output format that, if you don't like JavaScript, I'm sorry, there's no excuse. There are tons of languages that can compile to JavaScript. So yeah, you should be right back here with the rest of us writing web applications. What happened to my slides? Where'd they go? There they are. Right? And I'm obviously, hopefully, not going to talk about all of these. Okay? In fact, I'm going to talk about a couple of them, subsets, because they do represent a certain amount of thought, or in the case of the first one, TypeScript, a certain amount of momentum. How interesting is it to be alive today when Microsoft is taking over the web? Seriously, between TypeScript and VS Code. By the way, is anybody in here who did not know that VS Code is a Microsoft open source project? Because I do run across a few folks who are young enough to not realize that that's actually a Microsoft thing, and or a few people who are disconnected enough from the Microsoft universe to not realize that that actually VS stands for Visual Studio Code. One guy thought, no, it's just an acronym. No, it's really not. It's actually a Microsoft thing. TypeScript, right, is now the chosen language for doing things in Angular, for example, and TypeScript, in some respects, doesn't try to change any of the JavaScript syntax. It simply adds type bindings on top of it. We've got Dart, which is Google's player, right? Google actually has been interested in creating a number of new tools and languages, and Dart is their latest entry. Although, to be fair, Dart is actually being aimed a little bit more now at the mobile space. They have a mobile toolkit called Flutter, which compiles to native bindings on either iOS or Android, and Dart is really sort of getting tied with that very closely. So Dart as a JavaScript source is seeming to fade a little bit in favor of Dart being the language of choice for producing cross-platform mobile apps. But we'll still go over the syntax briefly. CoffeeScript is Josh Knass's baby because he looked at Ruby, he looked at JavaScript, and decided neither language was screwed up enough, so let's mix the two. So he's bringing Ruby to JavaScript via what we call CoffeeScript. For those of you who really like your functional languages, undoubtedly you have heard of Microsoft F#. Well, F# is an object hybrid language that will compile for JavaScript. So talk a little bit about Web Sharper, which is one of those efforts. And again, there are many in these categories. If, for example, you are a deeply functional person, because most of us aren't, right? Then you really like Haskell, right? Come on, Haskell programmers, show me love. Show me love. Show me Grant. There's none of you. Well, for those of you that want to pretend to be part of the hip, cool crowd, you can pick up Elm, which is basically Haskell for JavaScript for the browser. Yeah. Put that in your pipe and smoke it a few times, and it'll eventually start to make sense. Last but not least, and this is actually the real sort of crowning jewel in the whole package, the fact that so many people were targeting JavaScript as a target format, somebody somewhere at one of these big companies said, you know, it would be really helpful if we had a portable bytecode format that could actually be executed in the browsers and maybe standardized across all these different platforms, so that we could actually have, for the first time ever, a portable bytecode set that could be written once and run anywhere. Because we've never had that before. Right? Come on, some of you are old enough to get this joke. Nobody? Really? Nobody wants to admit it? Right? Portable bytecode set, right? All right, you guys are dead. Never mind. I'm not going to bother with humor anymore. So, just to be clear, I'm not going to be teaching you everything about these languages. As a matter of fact, I'm not even going to be spending a whole lot of time in these slides. The slides, there's about 120 of them in this deck there so that you can go look and consume this offline later. I'm really just trying to give you a sense of the feel of these languages and kind of what they look like, what their syntax feels like, etc. Mostly so that you can look at one and say, I'm intrigued, I want to go find out more, and then go do your own homework, right? Because at the end of the day, I have, 50 minutes in here, and I'm talking about 5 languages plus the standard WebAssembly thing. There's no time. There's no way you can learn a language in 10 minutes, no matter what the internet may tell you. So my goal here is basically to get you dangerous, right? I want to show you enough kung fu that you can stand on a street corner and look impressive, but if you actually get into a fight, you will get your ass kicked. Okay? That is literally my goal, is get you just enough so that you go, I want to study more about this. Go off, research that, study that. If you put this on your resume after this talk, do not cite me at all. I don't want to have any part of it. All right. Any questions? Going once, going twice. Last chance. All right, now you're stuck. TypeScript. Anders Hallsberg, the guy who invented C#, and before that Delphi. Anders is actually a fan of the typed language. He is also a fan of taking on interesting and hard challenges. And probably there is no more interesting and hard challenge for a language designer than to enforce type safety on top of a platform that has really no concept of type. JavaScript is actually built on a platform very similar to other languages. For example, one environment called Self, which was often spoken of in the same words as Smalltalk and so forth, which is a prototype-based language. If you go back and look at the JavaScript language, so much more begins to make sense when you realize that we don't have classes in the traditional typed object-oriented sense. We have an object, and I get to make a clone of that, so it will carry over the same properties and so forth, and actually have a link back to it, the prototype chain. But beyond that, there's no real relationship between these whatsoever. And I can doctor these things as we go. JavaScript is a full-fledged meta-object protocol, very similar to CLOS or Lisp or Scheme or so forth. And Anders wanted to bring type safety on top of this platform because, very frankly, compilers are really good at exhaustively testing scenarios that humans are not. I got into a really interesting debate once with Neil Ford talking about the value of Ruby and its dynamically typed environment against Java or C# or even more strongly typed languages like Scala and F# and so on. And Neil was like, hey, Ruby's great because basically it trusts the programmer. And I looked at him and I said, really? And you think that's a good idea? Because programmers, humans, are really good at exhaustively testing all of the possible ways code could go wrong. The people who are really good at that are called QA. And believe me, they are not human. No, seriously, if you've ever looked at a good quality assurance engineer, they do not look at the world the same way we do, right? I worked with a very, very good one once, and she filed a bug report. This was 20 some odd years ago, but it could have just have been yesterday. She filed a bug report where triple clicking a button caused the app to crash. Okay, just out of curiosity, how many people in this room have ever triple clicked anything? But the reason she did it is because she was watching our users sitting in the call center where they were working click on a thing. It wasn't responsive right away, so then they double clicked on the thing because they figured, oh, well, if one click doesn't do it, 2 clicks must. And thus they triple clicked this button, which caused the thing to crash. They look at the world very differently. Now, normally, when you're sitting and talking to Rubyists and JavaScripters and Pythonists and so forth, they will tell you, yeah, dude, that's what unit tests are for. And I will turn around and say, yes, and a compiler is a tool that has a whole slew of unit tests already built in that you don't have to write. And that was very much the mindset that Anders wanted to bring. The other thing that's kind of dangerous here, though, is there was an attempt to sort of bring more of these classic C, C++, Java, C# style, object-oriented typed features to JavaScript back in what we called ECMAScript 4. And ES4 is kind of like Star Trek 5. Nobody wants to admit it actually existed. If you Google for the spec, it does not exist on the internet. They have like wiped it clean. You have to go to the Wayback Machine to find references to it because it was so bad, it almost fractured the JavaScript community irreparably. This is why the ES5 release was called the Harmony release, and it was actually so very little there because they just wanted to bring everybody back into the same room, agree on a couple of errata, and then think about how do we go forward. Attempting to turn JavaScript into Java. And if you want to see what it looked like, how many people here have ever done any Flash developments? ActionScript is basically the proof of concept for what ES4 would have been.
And so many people in the JavaScript community were like, no, 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 this is completely changing the whole nature of JavaScript as we know it. So Anders wanted to try to get the benefits of typing without, like, potentially pissing everybody off. So what they did is basically started from ECMAScript 6. So a majority of the syntax you see with the TypeScript compiler is actually ES6 syntax. So class and the nature of properties and method, all of that is basically ES6 syntax. And then TypeScript just layers a degree of rigor and type checking on top of that, aided by developers providing hints to the types of return types, parameters, variables, etc. So to get TypeScript, npm install is your friend, -g TypeScript. You can also just play in the playground if you don't want to actually pollute your system with yet another Microsoft product. Couple of command line parameters. Again, not really something until you start using TypeScript in formal scenarios. Notice here, we have here some, wait, is this TypeScript or JavaScript? It's both. One of the principal goals of TypeScript is that any acceptable JavaScript syntax should also be an acceptable TypeScript program. So they start with the ES6 syntax, and whether I run this through the TypeScript compiler or just run it on top of Node, it'll behave the same. The key difference is whether or not the TypeScript compiler can spot problems ahead of time. So here, for example, if I actually start, if I pass in, instead of passing in the string world, I pass in 5, TypeScript will start having some fix. JavaScript, on the other hand, JavaScript's totally cool with it. Because JavaScript is the Birkenstock-wearing, granola-loving, free-loving hippie of San Francisco. It'll take anything. Be like, hey man, you want to give me a string? No, you're going to give me a number? All right, cool, we'll make that work. What TypeScript does let us do is it does let us pass in type parameters. So notice the :type syntax, the Pascal-style type syntax. This is becoming very popular in a lot of languages released in the last decade. And so now TypeScript can actually verify this and say, oh, okay, this is supposed to be a string, so therefore this concatenation would work. So therefore here, if I try to pass in an object instead of a string, then we're going to get a type error that the TypeScript compiler will flag, and presumably you, the programmer, will fix before you ship it. The key thing to understand about TypeScript is it all happens at compile time. Once we get past the TSC utility, the TypeScript compiler, then we're back to JavaScript. So what effectively is happening is TypeScript is taking the .ts files and transpiling them, yes, that's a word, transpiling them source to source, taking the TypeScript and turning it into JavaScript, and potentially adding some additional code to provide some support that TypeScript developers would be looking for. But in this case, it's going to be almost pretty much exactly a one-to-one transformation. We just take the type designations back out. Because once we've type checked it, once we've compiled it, then presumably we've caught all of the compile time errors, and anything else would be a runtime error based on either user input or the fact that the programmer received the compiler in some way. TypeScript types, pretty much the same ones that you're familiar with. Any number, boolean, string, void, null, undefined. Those are actually set up as types in TypeScript because there are times we want to allow null, but we don't want undefined, and vice versa. So we actually flag all 3 of those as types. Enums, objects, which again, most of that is just straight ECMAScript. And then nullability. By the way, for those of you who didn't know, the guy who invented null has apologized. Sir Tony Hoare, H-O-A-R-E, you can Google it, he actually stand up and gave a presentation. I believe it was a award he was receiving from the Association of Computing Machinery, and he called null his $1 million mistake. Based on the sheer number of null pointer errors that have showed up in my code alone, I'm pretty sure he's underselling it. I think it's a $1 million mistake. Unless we consider Perl, and then it's probably a $1 trillion mistake. Structurally typed. What this means is 2 types are considered identical if the structures are in fact the same.
So if I have a class that is first name, last name, and age, string, int, and then I have another class over here that is, let's see, city, state, population, string, int, those are actually considered the same type. Structural typing is different from nominative typing. Nominative typing is what we see in languages like Java and C# and so forth, where the name of the thing is what matters. TypeScript actually keys very strongly off of structural typing. And again, part of this is necessary because as soon as we get past compile time, we're in a runtime environment where it's just going to be string, int, and string, int. So off we go then. Now, TypeScript can also choose to give you some warnings. You can have linters running to help track those cases where, in fact, you may not want to be able to assign a city to a person, or vice versa. But that's kind of up to you as the developer. This is one of those things that TypeScript is exploring more fully as a language. By the way, TypeScript just recently reached a 3.0 release, and they are really starting to explore a lot of the area around generics and deeper type system stuff. So a lot of these slides were written for TypeScript 1 and 2, but 3.0 has some really interesting features which we will not get into. So here, structural typing, we've got a pair. Notice the angle brackets. Yes, TypeScript supports generics. So first and second are of two separate types, potentially. So here is a pair of string and number. And then down below, we see just an arbitrary JSON object. Notice that pair 2 is of type, arbitrary JSON type here, string and number. So now I can perfectly assign pair 1 to pair 2 and vice versa. Okay? As long as they structurally line up, then they're considered equivalent. TypeScript also captures classes as your standard C style. Actually, most of this is, aside from the colon string and the constructor parameter there, most of this is straight up ECMAScript 101 syntax. Okay, so if you've not seen ECMA 2015, 2016, 2017, I think the 2018 spec has come out now. Those are the official names of JavaScript, by the way, going forward. It's ECMAScript because it's actually the specification is owned by the European Computer Manufacturing Association. Go Europe. Yeah, good job. And they're doing yearly releases of the specification. Okay. ECMA 2015 and 2016 are usually collapsed into one ECMAScript 6 name, but they've started doing the yearly designation for any features beyond that. Here we see a little bit more of the syntax. So here we see public message string. What this is doing is this is actually declaring a property called message. Notice the use of public here. That says that this should in fact be a public property that will now be accessible. TypeScript introduces access control where JavaScript does not have it. Again, all of that is simply checked at compile time. If you go looking for it at runtime, it'll be there whether it's marked public or private. And then here we see greet is taking out, which is actually a function declaration where I'm expecting a function that takes a string and yields void. Notice the use of the fat arrow to indicate the return type. So that now I can use out, and again, TypeScript can type check because message is of type string and out takes a string, so it will verify that all of this works the way it's supposed to. Okay? In classic JavaScript, you could have just said out is whatever. And I could use it, I could test it certainly at runtime to see if somewhere along the prototype chain it is a function. But for the most part, I would just be assuming that programmers would be smart enough to hand me out an object that is actually a function, a closure, an anonymous function, etc. Here we can actually verify that, which is kind of the whole point. Classes can be grouped together into modules. This is one of the weaknesses in the JavaScript spec. Modules suggest that these can be packaged up and loaded and used, and that's one area where ECMAScript has kind of punted. Now they're working on trying to figure out module loading semantics, but that is all still very, very much up in the air. TypeScript can't do much for that other than say we can define things inside of a module and then we can make use of that. But for the most part, it's relying very much on ECMAScript going forward. And here, what we see, go back. So here we see module sayings. Notice the export. Export is actually a ECMAScript 6 syntax. This is saying that class greeter should be visible from outside of the sayings module. When we compile this, notice what TypeScript is doing. This is the actual compiled output, by the way, transpiled output.
Notice, first of all, we bury everything inside of a function and then execute it, mostly to create scope. Now, Implicit 2016 going forward actually has block scope variables if you use let and const. But for backwards compatibility, we still have to be able to support some of those older browsers that can't speak ECMA 6 natively. So this is a way to make sure that we get that same scoping behavior, but in a manner that can be consumed by older browsers. In this case, we invoke that function, looking to see if this is null. If not, we define it as an object. Here we are exporting greeter to say sayings.greeter is equal to this thing, this function, which we can then new up, etc. As transpiled output goes, that's actually pretty readable compared to some other stuff you might play around with. Classes can inherit from one another, so animal, snake extends animal. Again, constructor, we can call up to the base using super. For the most part, this is pretty much Java, C#, ish 101. And again, a lot of this is just ECMA 2015, 2016 syntax. Generics behave the way generics do. If you know C#, you can read TypeScript, the end. Okay? Now, interestingly enough, if you know Java, you can read TypeScript. And for a long time, I actually believe, this is that last bullet there, I believe that TypeScript's main benefit was going to be only those people who are coming from the Microsoft world into the web world. There's a whole generation of developers now who are learning TypeScript at various coding schools that have never ever set foot inside a Visual Studio. And they're loving TypeScript. Okay, don't be surprised. Right? So TypeScript is definitely taking over the world. If you want to go look at TypeScript, here's some more resources. Moving on. Dart. Dart is a language project that was started at Google. Dart has been in 2.0 state as its most recent release. Dart is available as a standalone download. It can transpile into JavaScript. Google originally said they built Dart because, quote, we care about the web. I personally believe Google built Dart because they saw Microsoft building TypeScript and said, we got to get in on this, otherwise Microsoft will take over the world. And then Microsoft said, hey, how about we partner with you to make TypeScript the official language of Angular? And Google said, okay. Which then kind of left Dart out in the cold, but then the Flutter guys picked it up, and so now Dart is kind of the principal language for doing Flutter development. You still can do a lot of stuff browser-oriented, but most of the Dart tutorials, most of the Dart explanations will still be very web-centric if you go back a year or two. It's class-based, optionally specified type checking. This is going to come up in a couple of scenarios. People are really getting, they're understanding that it's great to be dynamic except when it sucks. And if we can get the best of both worlds, that's ideal. If I can tell you when to do type checking, but then turn it off in those places where it actually gets in my way, that's probably a nice place to be as a developer. At least that's the belief. If you want to get Dart, if you're on the Mac, you can brew install. You can also install the Dart editor, which is an Eclipse-based IDE. Not my choice. Actually, if you want to do Dart today, if you've already got, what is it called? IntelliJ, thank you. If you've already got IntelliJ installed, there's actually a plugin that you can pick up for Dart that just, now all of a sudden your IntelliJ environment can start writing Dart code. There's also there's a Dart SDK that's included in Flutter. So if you grab flutter.io, if you're interested in mobile frameworks, Flutter is a good thing to check out, and it includes a Dart SDK to get you started as well. If you want to run Dart code, you can run it inside of the Dart VM, which is intended as a local VM to run your code. At one point, they were actually shipping a Dart browser called Dartium, which was modified Chrome. They took the Chromium browser, which is the core of Chrome, minus a lot of the user-friendly features. And they were giving you Dartium, but were very flagrantly telling you, don't use this for production. We don't expect Dartium to show up on everybody's desktop, etc. It was intended mostly as a way for you to play around with Dart. Most commonly, you would do Dart to JS if you wanted to compile your Dart code into JavaScript and then import that as a part of your web project. And here we see some Dart code. So notice, first of all, the typing is a little bit different. Instead of the Pascal style syntax, they choose to go with the more traditional type name before the variable name. Notice we leave off any notion of return type. That assumes void in that case. Notice here the $, this is basically string interpolation. So we're going to take a number and we're going to plop it into the middle of this string. Pretty straightforward stuff. And then we start executing the main function. Here we define a variable number of type 42. We pass it in, et cetera, et cetera, et cetera. Dart is going to type check this, at least as far as you tell it to anyway, and verify that you're not doing anything stupid from a syntactic perspective. If we want to do it inside of the browser, all right, we can import Dart:HTML. This is how we're going to pull in some of Dart's HTML support. And presumably this code is going to be compiled and loaded into a web page, right? We're going to Dart to JS this, then we're going to take that resulting JS and script source included, etc. So that here I can create a button, and then notice button .id, .text, .classes add, .onclick. This is basically, in other languages, would have been a with object do, and then open a scope block to do a variety of things. This is entirely to save you from having to type button.id, button.text, button.classes, button.onclick. We are effectively working with button in this entire block of code here. Okay? It's kind of a way to try to get a little bit of a fluent interface, as long as you're always referencing this property here off of button. And then at this point, I can grab body, .children, add button. This is obviously just straight DOM manipulation. Dart, interestingly enough, has two modes. They have production and checked mode. This is where it gets kind of interesting from a language design perspective. When you're working in developer mode, it does all of the normal type verification that we expect of a compiler. So it's going to be doing the static type checking, it's going to be executing assert statements and so forth. As soon as you indicate that you want to go to production, however, Dart automatically turns off all of those things. They genuinely assume that as developers, we will test our code in developer mode, catch all of those compile time errors, catch whatever runtime errors we can find, and then, and only then, do we flip it into production mode and ship it out to the web. If, I guess, you work at a shop like that. Notice that the third bullet, optimize for speed. When we get to production mode, they actually take greater steps to try to optimize all the code to execute more quickly. Primitive types looks pretty much the same as we saw from TypeScript because, again, fundamentally, JavaScript is still buried down there at the bottom of all of this. Here we see referencing some primitive types. Notice int.parse. Notice 1.toString. Dart is very emphatic in the idea that we should be extraordinarily consistent with our syntax. So if an int is a type, and you can create other types, and types can have static methods on them, then I should be able to call int.parse to parse a string and turn it into an int. Similarly, if I can take an instance of person and call a method on it, convert it to a string, I should be able to do that for any primitive type. So there, 1.toString, I'm basically calling a method on the instance of the object, which happens to be the integer literal 1. Now, most of the time, when you point that out to developers, particularly if they haven't spent a lot of time in dynamic languages, they immediately go, oh my God, are you telling me that everything is going to be an object? And they start thinking about the object overhead and virtual tables and all that stuff. As it turns out, the compiler is actually a lot smarter than that. When Dart, the compiler, sees 1.toString, it can realize that, yeah, that actually is an integer literal, so I can actually just swap in whatever the result. I can literally execute this at compile time, get the result, that becomes a constant, and we can eliminate that cost entirely at runtime. So the compilers are actually pretty smart. The goal here is for you, the developer, to have a consistent experience in terms of how you interact with your code. Here we see a couple of additional things. Hello world from Dart. This is all going to be concatenated together because these are simply string literals backed up against one another regardless of the white space. And then here we see what are sometimes referred to as here docs. So you have the triple quotes, the triple quotes. This basically says everything from this point forward we capture, including the white space, including the carriage returns. This is often used for command line documentation and stuff like that. String interpolation, handy, but it's also in ECMA 2015. Type checking, here we see name is Bob. JavaScript says you have a name, but if we run this in checked mode, Dart will complain because name is a string, not a Boolean value. And Dart will insist, as most languages do today, that if you're going to do a conditional, it has to evaluate to some sort of Boolean value. Since name is not a Boolean type, then you need to actually rewrite this to say if name not equal to null or not equal to undefined or something. You have to turn that into a Boolean test. Now, in this particular case, yeah, the language is probably being a little, over serious about the whole thing. Obviously, what we're trying to do is compare this against undefined to see whether or not that name exists. And it's obvious all the way up until it's a button. Dart is going to insist, if you're running in check mode, that you follow good type safe practices and make sure that's a Boolean before we continue. Again, the second block, Dart in unchecked mode. JavaScript is okay with that because one is truthy. Matter of fact, any positive value is truthy. In checked mode, if one will throw an exception because you're trying to use an integer where a Boolean is expected and that is not cool, Dart's going to get up in your face. A couple of symbols. The symbols are actually something that ECMAScript 2016 introduced. It's the idea that I can introduce what looks like a name but isn't actually a string. It's something that's recognized specifically by the environment. Most of the time it's used in ECMAScript for names that might accidentally clash with other things. Iterators use them, etc. Here, we can actually create symbols that represent identifiers that show up in your code, and this enables a certain amount of reflection capability inside of the language. Usual flow control constructs, right? Here we've got if, here we've got while and do while. These are all pretty straightforward. Again, you have to make sure that they operate on Boolean conditions in check mode. But as long as is raining is returning a Boolean, we're all good. The for loop, here you see we have a list. We're going to walk through the list, or we can walk through it by not caring about the actual index and just give me each one. However, Dart is going to encourage that you take more of the functional style approach and use the higher order functions like for each, map, etc., etc. That's generally the direction that a lot of language designers are trying to encourage us, including JavaScript. So if you haven't spent a lot of time learning about higher order functions, I would definitely suggest you do so. Switchcase, pretty much what you would expect. Notice the break is mandatory. If we want to actually fall down to the next case, we have to explicitly say continue and then do a label. The end. Functions look very much like typed JavaScript functions. So here, if I've got print number, notice here I'm saying you passed me number, you passed me times. Both of these are of type num. If you try to send me something that's not a number, Dart check will give you an error. Optional parameters I can provide. I can basically say print it is false by default, log it is true by default. Notice the curly brackets that surround those two. That means that you do not have to provide them, and if you don't, they will default to those respective values. If you choose to provide them, well, then you just simply have to name them and provide the values in question. Okay? First class functions. I have short name, which is it takes a string, and notice the shorthand syntax here with the fat arrow. Basically, this is, it's shortening up the syntax. This syntax, by the way, is actually coming to C#, and it's entirely possible that Java may adopt that at some point because Brian Getz has never met a language he didn't want to steal from. So I can say that, Brian's a friend. Here we see a list of strings, right? Again, notice the use of the generic. We want to walk through the candidates where short name, right? Well, let's see, short name comes from there, so name.length is less than 10. So effectively, this is almost a query, if you will, for a very, very, very simplified SQL-like type environment, and then I'm going to print each of the ones that are left over, those whose names are less than 10 characters long. We also fully support lexical closure and nested functions, basically meaning functions would behave the way you would expect them to if we start nesting functions inside of functions, and I can then return those functions to be invoked. Again, this is all functional programming 101 kinds of stuff. And Dart supports it, JavaScript supports it, but Dart will provide some type checking around it. Classes, fields, pretty straightforward. Notice, however, I've got last name and first name, and I've got age. The difference between those, last name and first name are both public. Age is private because age is prefixed by an underscore. Dart chooses to codify this convention so that if you start your class field with an underscore, it is private. And if you don't, it is public. Basically, it becomes a public property. Good choice, bad choice, I don't know. That's kind of for you to figure out as you play with the language. Personally, I kind of like it, simply from the standpoint that it's a convention and it is clear enough, once you know about it, that this is pretty distinctive. Particularly if you're like me and you grew up in the C++, Java, C# world, where the use of underscores was often, let's not use that, except in the specific case in C++, where we did some sort of very simple Hungarian-style prefix. M underscore field name, where field name would basically be camel case. The M underscore indicating it was an instance member as opposed to S underscore indicating it was static. But other than that, we never used the underscore for our variable names. I saw a lot of C++ code that used the underscore specifically to indicate it was a field as opposed to some other method or other object we were working with. So this actually resonates with me as readable. If you're a Java developer where underscores are really spawn of the devil and should never be used, then you may have a different opinion. And if you're from .NET, you kind of just will go with whatever the guy before you wrote anyway. So notice the person constructor here, this dot first name, this dot last name, that basically is a simple constructor that will take the first parameter and assign it to this dot first name and take the second parameter and assign it to this dot last name. It's a very succinct way of writing a constructor implementation. But then notice person dot singular. You know how we so frequently create static methods to be constructors, to be factory methods? Dart enshrines that directly in the syntax here by calling person.singular. We are telling Dart that this is a constructor function. And so now when I say new person.singular, we come here to allow us to instantiate the object and then invoke this as the constructor as opposed to this. Gives us a little bit more flexibility as we build out our domain types, particularly for those cases where we'd like to have a factory method, but again, we'd like the consistency. So you still call new, but then you say person.singular to indicate that you're calling that factory method as opposed to a standard constructor. Methods and properties pretty much do what you think they will. Notice string get full name. This is a property that's actually going to be computed from the standpoint that here, string get says this is the getter for full name. Notice the fat arrow syntax and then notice the Dart expression. This is essentially a property function. And then num get age will return the private age. Num set age, we will actually do a certain amount of value checking to make sure that we are not setting age to a ridiculous number like negative. Okay. There's also the ability to create overridable operators, operator overloading, which so frequently freaks people out. Dart says there's a lot of cases where it can be very useful to create overloaded operator syntax. Essentially, you create a function, the name will be one of these operators, and now you can define whatever you want in terms of its implementation. You can also have implicit interfaces. Actually, you get implicit interfaces regardless of whether you want them. This is a really interesting Dartism.
Whenever you define a class, it implicitly defines an interface and then also defines the class implementation. So here, person has a private name with a constructor and has a greet method. Notice that class imposter implements person. This is basically saying, I want this class to implement the person interface, the public face of this person. So here, for example, this final method, this final field here, name, this is in the interface, but this constructor is not because this is implementation, but this is in the interface because this is something that somebody could expect to be there, right? Because an interface is basically a promise of behavior. So when you create your imposter, you have to have the name, you have to have the greet method, but of course you can do whatever you want with it. And now any place a person that is expected, an imposter, can be slipped in its place. Is that a good thing or a bad thing? Okay. It's just interesting how Dart basically looked at Java, where we are constantly defining an interface and then an implementation of that interface, and said, why exactly do you have to define the interface? Let's just extract the interface from your class declaration, assume every class has an interface that it's going to implement, and go from there. And this will allow us to swap in different implementations without having to do any extra linguistic work. Inherence, dude extends person, the use of super, pretty much the same story. The override annotation serves the same purpose as it does in Java. The end. Dart also supports Mixins, which is the idea of let's create a class that has some behavior that you can consume in an inheritance-like style, but without actually defining a formal is-a relationship. So there's a couple of restrictions. It has to be abstract, it has no constructors, and you cannot call up to a base class because the mixin is supposed to be the whole point. It supports statics, pretty much the same way you do in any other of these languages. It supports generics, we saw a little bit of that already. Strongly typed collection literals, so here we see the bowling league consists of Walter, Donnie, and the dude. Bowling scores, notice that that is a string int tuple pair. Basically, it's a key value map. So Walter gets a 198, Donnie gets 196, and of course the dude was always a better bowler, so he gets a 217. Dart libraries basically are imported using the import keyword. You can construct them using library. And again, this is all part of the Dart universe. You can pull them in and make use of them. Export symbols via exports. But one of the things that Dart supports for its runtime environment is this notion of what they call isolates instead of threads. Interestingly enough, isolates were supposed to be a feature for Java 5. If you've ever spent any time with .NET, isolates are very similar to app domains. The idea is this is a full construct. Basically, we're like segmenting off part of the virtual machine and running code isolated, hence the name, inside that space. Dart takes that notion and says, sure, let's run with it a little bit. We're not going to try to build a full-blown, like, standalone application inside of the Dart virtual machine, but we will give each isolate its own memory heap, so that you can have multiple Dart applications running side by side inside the same VM, and they can communicate to each other through messages. In a lot of ways, this is very reminiscent of how Erlang communicates with the various processes and can spin up literally millions of them, as opposed to Java and its love of threads. If you want to find out more about Dart, dartlang.org, off you go. CoffeeScript. So CoffeeScript is an interesting bit in the sense that essentially Josh Knaus woke up one morning and said, I want more Ruby in my JavaScript. I want to actually close some of the syntactic holes that are in JavaScript by filling them in with certain amounts of Ruby syntax. It's, again, fully dynamic and untyped in much the same way that Ruby is. Now, let me be really clear about that. It's not to say that there aren't types in Ruby in the same way that there aren't types in JavaScript. There are, sort of. They just don't behave the way that C, C++, Java, C# developers expect them to behave. So as a result, we frequently refer to these languages as dynamic or untyped environments. It's node-based, npm install g CoffeeScript,
and then verify it. Coffee is the environment, -- version tells you what the latest version is. To be honest with you, it's been years since I fired up CoffeeScript, so I have no idea what the current version is. A couple of command line parameters, again, only useful if you want to actually spend a whole bunch of time with it. And then they actually said, you know what, the first pass I did kind of sucked, so I'm going to go ahead and rewrite it, what was referred to as CoffeeScript Redux. Now, the theory is you should actually be able to just use CoffeeScript and not realize whether you're on the old compiler or the new one. The new one was basically rewritten because once you get to a certain point, if you don't actually think about building a language the right way, you start breaking down. It becomes really hard to write a parser that works effectively, for example. So, in theory, Redux was supposed to replace CoffeeScript entirely. I honestly don't know if this has happened yet. I haven't looked. I think if you were to install CoffeeScript by this point, you're probably running the Redux compiler without even realizing it, but I haven't verified that. So, CoffeeScript looks pretty straightforward. Again, if you're familiar with Ruby, a lot of this syntax will be very familiar to you. If you're not familiar with Ruby, welcome. This is what Ruby looks like. I mean, it really is very similar. The hash is our comment character. Notice the distinctive lack of semicolons, right? The picture is just a fact. Notice the hash in the single curly brackets. This is basically string interpolation. This is actually executing this expression. This can be any valid CoffeeScript expression here. Here, call me Ishmael. Notice we don't actually terminate the string. We just keep going until we get to the closing character here. This will strip out the white space, so we just get one long string. If we want white space, then we again use the here.doc style syntax, the triple quotes, and this will capture all of the white space in between, most notably the carriage returns. Lexical scoping, right? Inner is part of change numbers and is not visible outside of that scope. So we can create a new variable called inner. Notice I don't have to actually put any prefix in front of it. I just say outer. And if this hasn't existed before now, it does now. There's no var, there's no let, there's no const. It's just, yeah, now there's a new variable. Off we go. Conditionals, if happy and knows it, right? If Friday, then Sue, else Jill. Obviously, this guy's got a really active dating calendar. Notice the switch, it's when Monday, then go to work, when Friday, Saturday, notice we just block and indent. If it's bingo day, go dancing. When, if it's Sunday, go to church, otherwise go work. Part of the idea behind the syntax of Ruby is that it should be something that feels very readable, right? Ironically, Ruby has a lot of Perl-isms in it, if you go look at the original source Ruby language, but a lot of the Rubyists tend to eschew the Perl. They actually would prefer you use more of this word-based, almost DSL-like syntax when you're writing Ruby code. Switch, when, notice the else, that's basically your default. Off we go. Switch returns a value, it is an expression, so here we can assign grade to whatever. It's either an F or a D or it's a pass. Notice, however, launch if ignition is on. So in this particular case, we're basically doing the conditional, but we're actually testing the conditional before we invoke the launch. Okay? This is just Ruby syntax. You just have to kind of get used to that. The volume is set to 10 if the band isn't Spinal Tap. No Spinal Tap fans in here? This one goes to 11. Nothing. You guys are tired. All right. Party on if the homework done is true. Party on unless the answer is no. Winner is yes if the pick is somewhere in that array, etc., etc., etc. Okay? By the way, the first one is the case here. The speaker is not really drunk. All right, let's see. Everything is an expression, so everything will yield a value. For the most part, everything is an expression. There are a couple of edge cases in CoffeeScript. Try catch actually will yield a value. So if you try and we divide non-existent by undefined, this is clearly going to yield an error. We catch that error. That error will actually be the result. The error will be what's passed to alert.
Okay? There are a number of languages that are actually taking up the idea that everything is an expression, because it actually makes the language a little bit more consistent and easy to work with. Arrays, they're arrays. Here, notice the use of dot dot, triple dot. These are all basically going to be slices of the array. We're actually going to be peeling off certain parts of it. So here, start is actually going to be the values from 0 through 2. We're basically slicing off the front. Here we're slicing out of the middle. We want to start the third in and go for 2 values. Here we want to start from the end and trim over. And here I want to copy the entire array. So there's a lot of power wrapped up in Ruby's array syntax if you know how to read the tea leaves. That's a little too subtle for my taste, but a lot of Rubyists love it. We also have loops and what are called comprehensions. Comprehension is actually a phrase we get from the functional programming community where we actually execute a body of code over something. So here, print food for food in. The for part here is basically saying we're going to go through this list. Each one is going to be put into food, and then we're going to print food. This is sometimes referred to more formally as a list or array comprehension. Here we're actually going to filter it. As long as the food isn't chocolate, we're going to print it, right? And here we're actually only going to grab the name for the name in foods when the name length is less than 5. There's a lot of power you can do in one of these comprehensions, which is why it shows up so frequently in functional languages. Functions syntax is very similar to a lot of other languages. Square takes the parameter x, gives us the result x times x. Notice fill down here, container and liquid, which has the default parameter for coffee. The skinny arrow, notice the single as opposed to the equal sign, the double hyphen. This is a single hyphen, also known as a skinny arrow. Filling the container with liquid. Variable argument lists. Object definitions. Math is, well, it consists of 3 fields, or 3 somethings. We've got a root, we've got a square, and we've got a cube. Square is a reference to the earlier slide. Square is a function. So we're pulling that in as part of the definition of math. Notice we have kids, we have a brother, we have a sister, etc. We can do comprehensions over an object. So here we're going to look at the child and age of years old. So that's basically going to be walking us through that list of name-value pairs. So child will get Max, Ida, and Tim. Age will get 10, 9, and 11 as we loop through that collection. Class definition, constructor, move is a method, snake extends animal, move now overrides what's in the base class, right? So now we can new up a snake, we can new up a horse. This is a little bit different than the Ruby syntax. They don't actually like using new. They actually use static methods. At least if I remember Ruby correctly, they prefer static methods. And then we can just dot, move, parens to invoke those methods. You can also write JavaScript or CoffeeScript as what they call literate. Basically, this is to mix and match documentation with code. In that case, basically, you're writing a lit coffee and with some markdown with code inside of indented blocks. And the whole point is, literally, if I'm writing a book, I can write it in this literate style, and the code can be executed and verified by the environment. This is great for documentation. Supposedly, the compiler is actually written in lit coffee as a literate programming language. I don't know if that's a great idea or not. Seems like a ton of work. But interestingly enough, Xcode has taken up this idea with what they call playgrounds. Xamarin has picked this up, and I would not be surprised if the JetBrains folks don't pull it into IntelliJ in some fashion, particularly now with Java. It's either 9 or 10 that exported the compiler as a module, which could be used, and the REPL came in Java 11, so now this becomes more possible to do inside of the Java space as well. So I wouldn't ignore this completely. It might actually show up in a Java world near you. Web Sharper, open source project to bring F# to the web. Websharper.com. You have to know F#. If you want to look at a full example, there's a calculator. And I'm not expecting a bunch of you to know F#, so all of this syntax will be new. But fundamentally, it's very similar to OCaml, if you spent any time with that in university.
So here I'm defining a module, I'm defining a main function, I'm doing some calculations. Notice the let parameter equals. Notice the refs there, that's basically saying we're referencing 0, and referencing none. This is very similar to ML, the old, not machine learning, I mean the old programming language ML, from which OCaml was derived. Here I'm displaying, I have an input with an attribute type of text and a value of 0, so when I update the display, I'm going to modify the value property on display with this particular string, making sure that it's either a string or numeric, if I remember the syntax correctly. Some operations, again, this is all basically functional style. F# is an object functional hybrid language, but Web Sharper basically wants to bring a lot of that functional love into the browser. We see the match syntax, if we're matching if the operator is none or some, so we have support for optionals in here. If you know what those are, great. If you don't worry about it. And in this case, we're going to set the caption on the button. We're going to take the button, we're going to take caption and action as parameters. We're going to set those. Here we're mapping up the onClick function to call the action, whatever that is, passed in. It's very terse, which if you know this language means you can express a great deal of power in a few number of keystrokes. If you don't know this language, it's complete gobbledygook. That's one of the biggest drawbacks to F# in my opinion. You can probably guess the div, the burs, etc. This is intended to be display code. So we're effectively defining each of these digits and these buttons. We've defined these primitives, digit and button, in previous slides, and now we're using them, and this will all turn into HTML. Lastly, Elm, again, very, very strongly functional. If you want to run it, you actually have to download Haskell and install that. That's usually the part where most people go, that's it, I'm out. Right, there he goes, he's out. Right? And again, most of this is just straight Haskell. If you're familiar with it, it will be very familiar. And if you're not, I'm not going to try to teach you Haskell in the next 30 seconds. Just kind of looking at the syntax, you can see it's, again, a functional language. You can see certain pattern matching going on here. We actually have what are called algebraic data types. We can define a type in a very, very small number of lines of code. You've got records, X is 3, Y is 4. The key thing about Haskell is it has no concept of object. So if you really want to play around with a language that has only functions and no objects, Haskell is a good popular candidate. Personally, I would point you towards ML because it's a lot simpler than Haskell. And the syntax is actually a little bit more English than symbolic. So I found ML quicker to pick up than Haskell itself, but the concepts are very much the same in both languages. The whole point is that this is Elm code. This code will actually be transformed and compiled into JavaScript, which then can be loaded and run inside of your browser. So just walking through more of this. There's a big full example of how to do a to-do application using functional reactive principles. That's what the FRP stands for. The main function is in todo.elm. The other 4 basically are sources to be compiled into JavaScript and then lifted into your browser. There's actually, if you go to Evan CZ, if you go to his GitHub and look at the Elm sources and whatnot, he actually built a Mario-style platformer game in Elm. If you really want to blow your mind around functional languages, the idea that somebody would build a presumably 60 frame per second video game in what is essentially Haskell in a browser, it's definitely different. And this is just more of the to-do code, which again, I'm not going to walk through. Here we go. The last bit I want to tell you about, if you're not familiar with, is not actually a language at all, it's WebAssembly. The whole point behind WebAssembly, if you go to webassembly.org, the whole point behind WebAssembly is to provide a compiler target. WebAssembly was actually born out of a project called asm.js, which is essentially a JavaScript library that looks very much like an assembly language. And there was a C++ compiler called mscripten, emscripten, and mscripten would take your C++ sources and compile it to asm.js. And if that sounds a little bizarre to you, it's going to get stranger because they actually did this for an old version of Quake.
The video game, Quake. They provided some graphic library bindings to WebGL, which is the OpenGL flavor that runs in most of your modern web browsers, and compiled it and ran it, and it was actually pretty playable. It was kind of cool, actually. You could be playing Quake in your browser with absolutely zero download besides navigating to that page. So in that sense, the concept has already been proven out. And the big browser manufacturers, Microsoft is on board, Google is on board, Firefox is part of Mozilla. Mozilla is actually where a lot of the documentation for WebAssembly is housed. All of them are on board with this. So in theory, what will happen going forward is rather than all of these languages transpiling to JavaScript, in theory now they will start transpiling to WebAssembly modules, which can be expressed either in a source format for those programmers who want to look at what's going on in compiled code, or in a binary format, which theoretically will be faster to load and parse, and therefore reduce some of the biggest problems with all of these guys, which is to say when they generate a whole pile of JavaScript to provide some of the semantics and support for the stuff that we see here, it makes it longer for your browser to actually come back and load your application. WebAssembly will hopefully correct for that. But this is still very much in the 1.0 state. I think all of the, if you go to the latest version of Edge, Chrome, Safari, Firefox, all of them support WebAssembly. How well they support it is still not clear. And if you are trying to use users who aren't on the latest web browsers, this is probably not going to be an option. But this is pretty clearly, at least as far as the browser manufacturers are concerned, this is at least one path to the future going forward. That we won't, Angular turns into JavaScript. It's entirely conceivable that Angular TypeScript compiler, the Angular libraries will compile into a WASM module that will get loaded by the browser and executed, and now the browser will have formally made the transition from something that displays HTML to full-blown operating system. Winning! Any questions?
If you would prefer TypeScript or Dart, which one would you go for?
TypeScript or Dart? It kind of depends on what I'm trying to do. If I want to write Flutter, it's Dart, no question. If I want to write Angular, it's TypeScript, no question. If I want to do React, it's TypeScript, no question. If I want to do Vue.js, it's TypeScript. Am I building a web app or am I building a mobile app? I don't know that I would use Dart for any of the web stuff today because that doesn't seem the direction they're going. I definitely like TypeScript. That is actually what one of my engineering teams use, and we've had a lot of success with it. So I'm a TypeScript convert. Of course, I never really got into the whole Ruby thing either, so CoffeeScript didn't really blow my skirt out. Any other questions?
Do you think Git is outdated?
Do I think which is outdated?
With GWT?
Do I think GWT is outdated? I kind of thought it was outdated the day it shipped. I was not a big fan of GWT. Anytime you try to do a thing on top of a thing, you start running into a lot of emulation differences and whatnot. And GWT got you 80% of the way there, and then you couldn't really figure out how to do the last 20%. So I was never a real big fan of GWT personally. Sorry. Any other questions? Going once, going twice, going home. See ya.